this is week 2 of IGB100 at QUT. Today we're going to get started work on the first game, which is a Shmup or shoot 'em up. Now, typical examples of this kind of game can be observed within the Raiden series, would be pretty popular. Also less popular games, but by no means less interesting. Ikaruga would be a good example, as well as certain other PC titles such as Baryon. This package you can find on the QUT Blackboard website within a zip folder, which will have some instructions regarding how to open it correctly. Within this scene is some assets already set up for the construction of this game. Most notably is a rotating skybox. To demonstrate this, if we just press play at the start of this, without actually adding anything, you can see that the skybox is automatically scrolling, which is great. It gives you that kind of moving through the environment feel. If you are interested in this kind of technology, do check out the Rotate Skybox script attached to the additional Skybox camera. In addition to this, there is also some models and effects that have been set up for you, ready to be used, just so we don't need to go and grab that content while we're actually walking through this. However, if you are more comfortable using your own assets here, by all means replace them, put them in, do whatever you need to do. So to get started making the shmup, we will first implement a basic player avatar. Now we can do this by creating a simple cube. So go to Game Object, 3D Object Cube. Let's rename this to Player and remove the Mesh Renderer and the Mesh Filter by right-clicking on them and going to Remove Component. We will also make this box collider a trigger, just so that we don't need to forget that later, and put its positioning back onto the origin at 0, 0, 0 on the X, Y, and Z axes. So, currently our player is nothing, it's just a transform and a box collider. Go to the models directory, to the Dark Fighter model, and drag that onto your player, and you should see a large model attached to it. Now we want this to be central to our player as a child object, so position it at 0 on the X, and let's scale it back so it's about 0.5 on the X, Y, and Z. Now you can do this manually, like I'm doing with precision here using the transform component, or you can do it using the tools that were discussed in the previous video. I like precision, so I'm going to stick with this. Finally, let's put it to -90 on the Z so it's facing forward. And as you can see in the game scene, our ship is almost ready to go. So let's put some basic controls on our player. To do this, we will make a new script. Yes, we're already getting into the scripting. So right-clicking on the scripts folder within your assets directory, go to Create C# script. Now, important, don't click off immediately, otherwise you'll call your new script new behavior script, and we don't want to call it that. Let's call this script player. Now, open that script up in your editor of choice, but if you do prefer to use a different editor, you can go to Edit, Preferences, External Tools. And I've got mine currently set up to be Visual Studio 2015. You can change that to whatever you want if you prefer something else. So double click on the player script and we can load up Visual Studio. So with the player script open in your editor of choice, we can start scripting. First of all, let's add a float to our script. This will be a public float move speed. And by default we'll set this to something like 50. Feel free to change that. Keep in mind that any variables that you make public within your scripts you can also access within Unity. They'll be adjustable within Unity, but any values that you change in Unity will stick. So if you go back and change them within the scripts, they won't be the same, so you need to keep that in check. So we'll add a public float move speed. And we'll also include a vector3 which will be called position. Now this is just going to keep track of the position of our player, and we don't need to initialize that with any kind of variable. So within update, let's first of all do a couple of things. Let's make our position variable equal this object's transform.position. So we can say transform.position. So what that's going to do is every game loop, every loop of update, the position of our player is going to be updated, and it's going to fill this variable here, position. I then immediately after that want to call a method called movement. Now this method doesn't exist yet, so underneath updates, let's make a new private void movement, and we'll just leave it like that for the moment. Finally, at the end of this, I am going to use movement to update some kind of movement, and then I'm going to say that our transform is then going to be equal to our position. So that should actually be transform.position. Now, within movement, we will actually put the code that will control the actual translation of our ship. So let's call this method, or at least give it a comment, that is essentially something to do with player input controls. And here we can put the first control, which will be right movement, and this will actually use a if statement, a conditional check, that checks the input for get key, and this key will be D. And all this is going to do is that when the D key is being pressed, the position dot x will be plus equal to move speed times time dot delta time. Now some of you may be thinking, what on earth is that? Time dot delta time, or delta time, is essentially the time between frames, and it acts as a useful coefficient for normalizing the performance of your game based on the frame rate, so that objects like players, objects like projectiles, move at the same rate regardless of which machine they're on. Whether they're on a slower or faster machine, it doesn't matter. If you multiply it by delta time, you're right. So right movement, let's talk about left movement. Going to be very similar. I'm actually just going to copy this, and instead I'm going to make that A. And this is going to be minus equals. Finally, let's do this for up and down. So up movement, and instead this will be W, and instead of the x-axis we're going to talk to the z-axis, and we're going to add. Finally, let's copy all of that again. For down movement, let's make this instead S and minus. So basic WASD movement. If you really want, you can make that something else. You can make it the arrow keys. We'll get to more complex movement types later, but for the moment that should work just fine. So save this script. Always save your scripts before you go back into Unity and test them. Quick way of doing that, just go Control S, go back into Unity, attach your script to your player. As you can see, the move speed variable is a public variable that we can change within this script, but without actually touching that at all, let's just play the game and see if we can move as intended. There we go. Basic player movement. So the next thing we're going to do regarding making this a little bit more like a shmup is to give some basic interactive functionality. In the case of most shmups, that's generally blowing the crap out of things, so shooting projectiles. To do that, let's first of all make a new game object, 3D object cube, and let's rename this to something sensible like a bullet or projectile. Let's take the mesh renderer off, let's take the mesh filter off, and let's put this back on the origin as well. It's not really going to matter in the case of a projectile, but we'll be able to gauge its size with relation to the player ship. So that's how big our projectile is roughly going to look. We'll make this a trigger, as well as give this thing a rigid body. It's going to interact with things in a physical sense, so giving it a rigid body makes sense. We'll untick gravity because we don't want this to actually fall down. We are in space, so there's going to be very little gravity anyway. Finally, attach an effect that is actually a trail renderer to this, giving it kind of a bullet or laser-like effect. And we'll just change a couple of properties of this before we move on. The first being a material. So extend the materials list and click on that little circle at the end. And if you just type in sprites, we'll get a simple sprite effect for our bullet. The other thing we do want to do is adjust the time or length that this trail renderer lasts for. So instead of 5 seconds, that's actually a really, really long time. Let's make that 0.1 instead, and we can leave the width at 1. We might want to tick the auto destruct box though, probably doesn't matter too much. So you can actually see now if your bullet is having the effect that you expect. So you can do this by actually just dragging the bullet around the scene view. And as you can see, it's actually leaving that trail renderer at the time and width and length or whatever other settings you've set up already. So that's just a good way of previewing what this bullet is going to look like. To actually make it move by itself though, we will need to make another script. So to right click on your scripts, go to C# script and make a new script. We'll call it something like projectile and just open that up in Visual Studio as well. So projectile is a completely new script. This is something that we will need to set up individually for the projectile. It'll be different from the player. It's going to be slightly different in the sense that, first of all, our projectile is going to need a lifetime. So make a public float called lifetime, and we'll make it by default equal to something like 3 seconds. Now, interestingly, you can use a command here to make the projectile only last as long as you want the lifetime variable to be. Within start, you can issue what's called a destroy command, and we can overload this by saying it is this game object, as in this projectile, this thing that we're talking about, and we can give it another parameter, that being the lifetime. And the game will understand that when this thing starts, you're telling it to destroy this projectile or this game object 3 seconds from now. It's pretty smart. So let's continue. Let's give this another public float. We'll call this one movement, or maybe move speed, and we'll make that equal to something pretty quick. I'm thinking something around the realms of 350 would be nice. So that should be enough just to get our projectile doing its thing. In update, let's make a method call to a movement function, and below update, let's make a private void movement, and within movement, let's just write one line of code, that being the transform dot position is plus equal to time dot delta time multiplied by the move speed. So very similar to what we had in the other line of code for the player. But because we only want this to move in one direction, i.e. forward, that's all we care about. So we can say we want to multiply this vector by the transform dot forward vector. Maybe don't put a comma in there. So saving that script, go back into Unity. It should update here if you did have it selected. Select your bullet. We'll just close down some of these components because it is taking up a bit of the screen. We don't actually care about some of them anymore. And attach the projectile script. So, if you wanted to test this out now, you could zoom a little bit out, make sure you have the bullet selected, and just press play. It should take off, probably too fast for you to kind of look at it properly. That's okay. What we'll do now is, as I discussed in the previous video, make this bullet a prefab. We want to be able to shoot this thing out on multiple occasions whenever we want. So to do that, grab the bullet, drag it into the assets folder somewhere, and you should get a bullet prefab appear that has all the settings that you have of the one that's in the scene. We don't want this scene bullet anymore, so let's just delete it. And if you did it right, the bullet prefab should still remain in the assets folder. So let's get this player actually shooting these projectiles. To do this, go back to your player script in Visual Studio. Now we need to add a couple of new variables to control not just the shooting of this, but we also want to control the rate of fire. So we're going to introduce a little bit of code that kind of talks about the idea of a timer. First of all, let's make a public game object projectile. And that's not going to be initialized with anything. This is going to be us dragging that bullet prefab that we just made from Unity into this public variable within Unity. We'll do that in a little bit. We also want to make a public float. Whoop. Not that. Make a public float. We'll call it fire rate. And let's make it something pretty fast, maybe 0.1f. Yeah. We also want to have a timer. So let's make a private float fire time, or timer if you want to get correct. That should be enough. So, going into the update section of your main loop for this object, underneath here, let's make a new method call to shoot. Now we haven't written this method, so underneath update, let's make private void shoot. To do this, we need to consider the button that we're actually going to press, whether that be a mouse button or a keyboard press or a control. In this case, I am going to make it a keyboard input. So that's going to be input.getKey. And I reckon the spacebar will probably be sufficient for now. However, I want this to fire at a particular rate. I don't want this to fire in every instance that the game picks up that the spacebar is down. Otherwise the fire rate would essentially be our frame rate, which is not good. That's pretty imbalanced. So let's instead make that have a conditional that's an AND statement. So it's checking for if the spacebar is down, and I'll just put the correct brace there, and if the current time is greater than the fire time. Then let's do something with that. And all that we're going to do is instantiate our projectile And we're going to do this at the transform.position and transform.rotation of our player. Finally, if we want this to fire at the desired fire rate, we have to tell it that. We have to tell it the next time to fire, i.e. the fire time or timer, is whatever the time is now plus the fire rate. So that'll give us that interval of shooting that we would prefer. So save that script, go back to Unity. If you've done it correctly, you should not get any red errors, but most importantly, you should get a couple of new variables appear in your player script. The first one being the fire rate, second most important being the projectile. What you do now is drag the bullet prefab from your assets folder into that projectile variable. So, when you play the game now, not only should you be able to move, but if you hold space, you should be able to shoot projectiles as well. So what you should consider now is actually the idea of tweaking some of these variables. Like, I have introduced a player that has move speed of 50, has a fire rate of 0.15. The bullets moves at a speed of 350. You may want to make that bullet faster or slower. You may want to make the player shoot faster or slower, or move faster or slower. You can actually even do a couple of interesting things. Maybe you don't just want to shoot one projectile. Maybe you want to shoot 3. Maybe the direction that the projectiles come out is in typical Shmup format all over the damn place. There's a lot you can do with this current system that'll make your game play differently than everyone else's. So do have a think about what else you can do here. If you do have some design plans already, now would be a great time to implement them, especially with the help of the tutors. So if you're actually in class right now, do let the tutors know, we'll give you a hand. Otherwise, that's it for the week. Next week we'll be expanding on the Shmup a little bit more.